Hey guys, welcome to part B of lesson 1. What we are going to be doing now with complex numbers is multiplying and dividing. Okay, so this first part is going to look really familiar. This is where we have to use that FOIL method for example 1. Just like when you were learning about quadratics, it's a very similar concept here. So we got to take the first terms, multiply those. So 3 times 5 gives us 15. Then we do the outside, so 3 times 2i gives us 6i. Inside is 4i times 5, which is 20i. And then 4i times 2i gives us 8i squared. Because remember, if you have two i's multiplying, you get I squared, just like if you were taking x times x. So then the middle part becomes 15 plus 26i, combine the like terms. Now 8i squared, remember this is the same thing as -1, so it becomes 8 times -1, which is minus 8. So now we can just combine like terms. So combine 15 and -8, we get 7 plus 26i at the end. Okay, let's go ahead and try the next one here. Start with 2 times -6, which is -12. 2 times -2i, which is minus 4i. 3i times -6 is -18i. And then 3i times -2i is minus 6i squared. We combine our middle terms, so we get -22i. Now this over here becomes a -6 times -1, which becomes +6. So we really have to be careful with those I squareds. It always changes the sign. So then combine the like terms on the outside, -12i and +6 gives us -6, and then minus 22i at the end. Last one here. Now notice, these are, what we call this is multiplying binomials because there's two terms inside the parentheses. Bi means 2. So 1 plus 2i and 1 minus 2i. If you remember, this is called a difference of squares. And it has a special product. So 1 times 1 is 1. 1 times -2i is minus 2i. Positive 2i times 1 is plus 2i. And then 2i times minus 2i is -4i squared. Okay, so 1, and then the middle terms here actually cancel each other out. So we get 1 minus 4i squared. But remember, I squared is just the same thing as -1. So we get 1 plus 4, because these two would multiply and change their signs, which ends up being 5. So oddly enough, even though we were multiplying with complex numbers, we ended up with a real answer, which is just 5. So that will happen. Example 2, now we're getting into rationalizing the denominator. This is like dividing with complex fraction, or complex numbers, excuse me. So write the quotient in standard form, multiply by the complex conjugate. The complex conjugate is whatever the complex number is on the bottom, but it's the opposite sign. So notice, this is 1 plus I, so the opposite of that would be 1 minus I. We only change the sign that's in the middle. So we need to multiply by 1 minus I on the top and the bottom. And remember, if you multiply by a fraction that's the same on the top and the bottom, we're technically only multiplying by a form of 1, because anything divided by itself is 1. And now we're just going to apply what we were doing up top. So the top part, when you distribute to everything, follow the same procedure. So 2 times 1 is 2, 2 times -i is minus 2i, -7i times 1 is minus 7i, and then -7i times -i is plus 7i squared. The bottom becomes 1 times I is -i, positive I, and then I times minus I is -i squared. Okay, then we simplify the top. We get 2 minus 9i, and then this becomes the opposite sign, so it's minus 7. The bottom becomes, these are just going to go away, and we get 1 plus 1 because this becomes the opposite, so negative, negative. Then simplify the top, we get 2 minus 7 is negative 5 minus 9i over 2. And that's as simple as we can go for right now. So that would be our answer. I guess if we were going to write this in standard form, I forgot this, you would actually take 2 and separate it out into two fractions. So it would be minus 5 over 2, where we just look at this part, minus, and then we would separate it with 9i over 2. So these are technically the same answers. I would accept either one, but this is standard form. Okay, let's keep going here. Do the exact same process. So the complex conjugate this time, since negative 2 plus I is on the bottom, we need to multiply by negative 2 minus I. We only change the sign that's in the middle. Okay, so distribute 3 times negative 2 is negative 6. 3 times negative I is minus 3i. I times negative 2 is negative 2i, and then I times negative I is minus I squared. The bottom, we get negative 2 times negative 2, which is positive 4. Negative 2 times negative I, which is plus 2i. I times negative 2 is minus 2i. And then I times negative I is minus I squared. So now the top, we simplify that. Negative 6 minus 5i when we combine our like terms. And then minus I squared, remember, opposite sign, so we get plus 1. And then the bottom, these are going to go away, and if you haven't noticed, this pattern is going to continue every time. So 2i and negative 2i go away, and we end up with 4 plus 1. So the top, when you combine like terms, we get minus 5i over positive 5. Now here, we should definitely simplify. Divide 5 into both terms. So 5 divided into negative 5 is negative 1, and 5 divided into negative 5i is just minus I. The 5 goes away there. So this is the simplified standard form. Now the last one's a little bit trickier because we're introducing a radical, so that's going to make our answer a little bit wonky. So what we multiply with this one, our complex conjugate, is going to be 2 plus I times the square root of 5. So we're going to do that on the top and the bottom. So go ahead and distribute. 3 times 2 is 6. 3 times I squared of 5 is 3i squared root of 5. This is kind of an ugly answer. Then we jump over here. We get 2i squared root of 5 when we multiply those. And then I squared root of 5 times I squared root of 5 is I squared square root of, if you multiply the two radicals, you get 25, which will reduce. So we'll talk about that. And then on the bottom here, 2 times 2 is 4. 2 times I squared root of 5 is 2i squared root of 5. Then distribute the negative I squared root of 5, which is minus 2i squared root of 5. And then the last part is minus I squared square root of 25. Okay, now that looks nasty. So let's go ahead and simplify. So 6 stays the same. These two are technically like terms, so we can actually add them. So it's 5i square root of 5. Just add the 3 and the 2. Basically, that's all that changes. Plus, now this part's a little bit weird. So I squared we know is negative 1. The square root of 25 is a nice number. It's just 5. So when you multiply these two together, we get negative 5. Now the bottom, 4 stays the same. These two cross each other out, and we get, this is negative 1. So we get minus, and then this is 5. So if you multiply those, you get negative 5. But since we have two negatives here, this ends up being a plus. So let's simplify. This part right here ends up being minus 5. So 6 minus 5 is 1, plus 5i squared of 5. And then the bottom, 4 plus 5 is 9. So this is one way you could leave your answer. I'd be fine with that. But the standard form would be to divide 9 and make it into two separate fractions. So it would be 1/9 plus 5i squared of 5 over 9. Not a pretty answer, but that is how we do it. Okay, so try those student problems. You got 3 of these here. And let me know if you have any questions. You might have to go back and rewatch some of the examples. I apologize, this is definitely a weird concept to teach in a video, but do the best that you can and send me any questions that you might have.